Okay, students, this is section 3.4 notes, but only part 1. We are splitting this section into 2 sections, and we are going to continue working with special right triangles when it pertains specifically to reading the unit circle. So let's dive into these problems here. We're going to do a few on that worksheet that has been provided to you. There are 30 problems on that note-taking guide, but we are not going to do all of those problems. We'll probably do anywhere from 8 to 10 problems. So we will start off with number 1. So I am going to ask you to find the exact value of a trigonometric function. In order to do so, we are going to go over some formulas first that are going to help you be able to do this without the use of a calculator. So there's another worksheet I gave you, a handout, a formula sheet, where if you glance towards the bottom, you'll see what is displayed right now on the screen. You have the unit circle, and then you have some formulas that you will need to now memorize outside of the ones you used when solving right triangles, which was sine is the ratio of opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over hypotenuse. So instead of using that formula definition, you're going to start using the ones you see right here. So sine on the bottom right, sine is going to be your y coordinate on the unit circle. Cosine is going to be the x coordinate. Tangent will be y divided by x. Cosecant, secant, and cotangent, you will note, are all the reciprocals of sine, cosine, and tangent. So notice that they all just got flipped, okay? The numerator became the denominator, and the denominator became the numerator. Okay, I know this unit circle is a little blurred, but hopefully you have your formula sheet in front of you and have a better clarity of a picture being depicted. Okay, so let us go to our problem number 1. So tan theta, so first of all, just in case you're not familiar with that symbol, that's called a theta. Tangent of theta is going to be what we're evaluating. Now, theta, from here on out, it will always be a variable that is representing our angle measures, okay? That will always be our angle measure, whether it's measured in radians or degrees, that's what theta represents. So in this particular problem, the picture shows us that they want us to evaluate the tangent of 60 degrees. So I'm going to rewrite tangent of theta as tangent of 60 degrees. So all I did was merely substitute theta for 60 degrees. Now, when you go try to evaluate tangent of 60 degrees, what we need to do, I'm going to go over back to our formula sheet, is go look to see what tangent requires us to use. And tangent requires us to know what the y and the x coordinate of our unit circle is at 60 degrees. So right now we are at 60 degrees. Here's my 60 degree measurement. And so the x and the y that you're going to use are these two values right here. 1/2 and square root of 3 over 2. So I'm going to go back over here and tell myself, okay, I know tangent is y divided by x. So I'm going to substitute the y, which we just saw was square root of 3 over 2. And then I'm going to divide by the x coordinate, which was 1 over 2. Now we have a complicated, well, not so complicated, but a crazy looking stack fraction. The great thing about using the unit circle is that all the denominators of our values in the unit circle are going to either be a 1 or a 2. So notice that this 2 in this denominator and this 2 in this denominator can cancel out to be 1, reduce. Now, what's left over? Square root of 3 over 1, which is simply just square root of 3. and we are done, okay? So I challenge you to try something out. I challenge you to go into your calculator and type tangent of 60 degrees, okay? I want you to type tangent of 60 degrees. Make sure your mode is in degrees. Get an answer, and then I want you to type square root of 3 in your calculator. And what you're going to notice is both of those values are identical. But notice as well, right here, I had told you guys that in the instructions, it's kind of zeroing out there let me erase that here. In the instructions, I'm telling you to give me the exact value. Exact value means that I do not want decimal value answers. So you cannot just use the calculator to type tangent of 60, because you're going to notice that it will give you a decimal value. Okay? So let's try the next one, number 2. Number 2 is the sine of the given angle. In this case, it's 225. So I'm going to write equals the sine of 225 degrees. So let's go over to our unit circle over here. And this time we are going to look at sine. So sine in this case requires us to look for the y-coordinate. So I'm going to go to 225 degrees, which is this one right here. Okay, so my angle would be 225, by the way. That's how you read the angle. Okay, so I stop at where 225 degrees is, and I notice that my y-coordinate is this one right here, negative square root of 2 over 2. That's what I'm looking for. So all I do is say, well, the y-coordinate of 225 is negative square root of 2 over 2. And I'm done again. Okay. Let's do the next one. Again, sine of 90 degrees is requiring us to find the y-coordinate. And the y-coordinate at 90 degrees, let's go over here. Let's use a different color. So 90 degrees is, we start from here and we rotate and stop at 90. 90 degrees is right here. And the y-coordinate is a 1. Okay? Cosine of theta. So we now do cosine of theta, the given angle substituted to be 150 degrees. Then we go back to our unit circle and our formula, and we see that, well, cosine is what? Cosine formula, orange I'm going to use, is our x-coordinate, okay? And we're asking to find the cosine of 150 degrees. So that means I start right here and I open up until I get to 150. That's my angle for 150. 150 is this dot, that angle, and we were asked to find the x. So I use the first coordinate, negative square root of 3 over 2. So I needed to look for the x, and negative square root of 3 over 2 is the final answer. That's what you would type on your Delta Math, okay? Okay, so far, hopefully you're okay with that. So let us come over here and do a tangent problem. No, not a tangent problem. Oh, we still have cosine and a tangent problem. So how about you pause your video right here and work these two problems out on your own, and then check your answers. Okay, welcome back. So here are the two problems that you should have worked out on your own. Cosine of 90 would be the x value at 90 degrees, which is 0. Cosine of 240 is the ratio of y over x at 240. And as you can see, the 2's still cancel out, the negatives cancel out, and square root of 3 divided by 1 is just a square root of 3. Okay, let's move on to the next problem. So here are problems now. Instead of angles being given in degrees, they're giving it to us in units of radians. And instead of giving us a picture of where the angle is located and whatnot, they're having us look for the angle on our own. Okay? So cotangent of 7 pi over 4. So again, we still are going to resort to going to our formula sheet if we haven't memorized it. And we notice that cotangent is going to be the ratio of x over y, okay? So let's come back over here and tell ourselves, okay, for cotangent, I need an x coordinate, I need a y coordinate, and I specifically need to find those 2 coordinates at 7 pi over 4. So I come over here and I look for 7 pi over 4. So I notice right over here is pi over 4. And I need to just keep counting around until I get to 7 pi over 4. And I notice that 7 pi over 4 is right over here. Okay, there's my 7 pi over 4. So I had to wrap around, all around until I got to 7 pi over 4. We need the x and the y. So x and y are those. So I'm going to take those values and substitute. So I had a square root of 2 over 2 divided by a negative square root of 2 over 2. Well, notice that those numbers are both identical. So my answer is merely going to be a negative 1. If you wanted to say, okay, I canceled here, and that means square root of 2 is over negative square root of 2, and that equals negative 1. You could have showed me all that work as well. It's up to you, but that's it. That's your answer. Let's do cosecant of 2 pi over 3. So here's something that I want to introduce to you guys, because that's going to be the case on 2 of these trig functions that I want you to always make a note of, okay? So the 2 functions that I'm talking about specifically are these 2 right here. So I'm going to box them in to draw attention to them. And I would like for you on your worksheet to please write the following, okay? So you don't need to box it on your worksheet, but I'm trying to get your attention right now. I want you to, and how can I do this? Let's see, you know what? Cosecant, let me write it over here. I have more space over here. Here's what I want you to write at the bottom of your worksheet. So you have cosecant of theta is equal to 1 over y, and you also have secant of theta equals 1 over x, okay? Now, what I would like you guys to do is get in the habit of not reading this as follows. So notice I read it as cosecant theta equals 1 over y, secant theta equals 1 over x. I don't want you to read it that way. I want you to read as, so on your paper write this, read as reciprocal of y, and I want you to read this one as reciprocal of x, okay? So I want you to read it again, not cosecant theta equals 1 over y. I want you to say cosecant theta equals the reciprocal of y. Secant theta equals the reciprocal of x. That's how I want you to read those 2 formulas. All the other formulas, read it as you see it, okay? Sine is y, cosine is equal to x, tangent is y over x, cotangent is x over y. But these 2, read them with the word reciprocal. And remember, reciprocal just means that these two numbers are going to interchange, okay? That's all reciprocal means. So keep that in mind, okay? All right, so why do I say all of this? I am going to go back to my problem. Here's my problem. Cosecant of 2 pi over 3. So cosecant 2 pi over 3 is equal to, if we look at our problem, again, our formula sheet, it is the reciprocal of y. Okay, so I'm going to write this down. Notice I did not write I didn't say 1 over y. I said it's the reciprocal of y. So I'm going to go to 2 pi over 3 on my unit circle, and I'm going to find my y. So 2 pi over 3, are you looking with me? Okay, so hopefully you found it now. So I rotate, and here's 2 pi over 3. I stop right there. So 2 pi over 3 is right here, and I need to look at the y coordinate, okay? Square root of 3 over 2. So what I want you to do is this. What people are going to want to do is write it like this. 1 over, I'm going to put it in pink, square root of 3 over 2, okay? That's how you're going to want to write it. But I do not want you to write it that way. Remember, I told you guys, I don't want you reading it as 1 over y. I don't want you to do that. I want you to tell yourself that you are looking for the reciprocal of y. Now, you know that your y is that number. So if I ask you to find the reciprocal of y, all I want you to do is flip it. Flip your y. That's all I need you to do. So my answer right now is 2 over square root of 3. Okay? Do not write it like above. I don't want you writing this. Okay? Don't write it this way. For those two problems, for cosecant and secant, all I want you to do is take the reciprocal of the x or take a reciprocal of the y. So in this case, it's the y, so you flip it. Now, I do want you to notice, though, that when we flipped this problem, we ended up with a rational that has a radical in the denominator. So I need you to get rid of that radical by rationalizing. So I need you to multiply top and bottom by square root of 3. You are still going to rationalize just like you've done all along. Okay, so my final answer in radical form is going to be 2 square root of 3 over square root of 9. That simplifies to 2 square root of 3 over 3. So this is my answer. Okay? So reciprocal of y, just flip it. That's all you need to do. Okay, moving on. Let's see. Let me erase this. Okay, so now we're going to do cosecant of 225. Here's another one, okay? So cosecant, what does that mean? So we look over here. Cosecant is this one, all right? So cosecant equals, I'm not saying it. What am I supposed to say? The reciprocal of y, not 1 over y. So I'm going to go to 225. I'm going to find it. So I take my eyes and I rotate until I find 225. So I'm right over here. And my y coordinate is this one. And I am supposed to take the reciprocal of it. So instead of negative square root of 2 over 2, it's going to be 2 over negative square root of 2 over 2. 2 over negative square root of 2. Okay? Again, we need to rationalize. So I'm going to multiply top and bottom by square root of 2. You can multiply both top and bottom by negative square root of 2 if you want. I'm just going to pretend that the negative is upstairs. Okay? As a matter of fact, that's why most of the time math teachers would just write the negative right here, because it could go with both top or bottom number. So anyway, my answer now is going to be 2 times square root of 2, which is going to be 2 square root of 2 over square root of 2 times square root of 2 is square root of 4. But we know that the square root of 4 is just a 2. And then we notice that this 2 and this 2 are going to cancel out. And so the answer to cosecant of 225 is just square root of 2. Don't say radical 2, okay? I hear it too many of you students reading it that way. It's square root of 2. Okay, yes, it is a radical, but it's a square root because that's an invisible 2 index in that specific spot. Okay, so that's number 15. Let's move on to another problem, number 21. So I believe this one, okay, so we're going to get a little bit more complicated on this one, but not too much harder, okay? So grab that unit circle. Let me show you guys what you're going to do. Okay, coming over here, I want to remind you guys of how many sections we have or angles we have in one revolution for the 3 different special angles of 30, 45, and 60, okay? But we're thinking radians right now, so we're going to look at pi over 6, pi over 4, and pi over 3. So what I mean by that is this, okay? So from here to here is pi over 6, correct? So I'm looking at this particular wedge right here, all right? So if I asked you right now, how many of these wedges do we have in the top half of the unit circle? I want you to notice that you would tell me that there are 6 of them, right? Do you see them? 1, 2, 3, 4, 5, and then 6. All right, do you guys notice? So if I kept counting around, we would have, of these size, we ended up with 12 of them if we counted all the way around, okay? So there are 12 wedges, for lack of better words, that are pi over 6 in size, okay? Now, what I want you to notice is if you want a quick way to remember how many pi over 6s we have, notice right here, this is the last pi over 6 before we make the whole full circle, okay? So if I had to go a little bit further, this much further, I would get to the next number that comes after 11, which makes 12 pi's over 6, right? That's what that is, all right? So keep that in mind. Now let's do another one, okay? Let's do pi over 4. So pi over 4 goes from here to here, so that's this wedge. How many of those wedges do we have in the top half? Well, notice that we have 4. Correct? Okay, so that means a total of 8. But again, teaching you the fast way. Okay, we've established that there are 8 pi's over 4s. But again, if you wrap around all the way to the last pi over 4 we have, it's 7 pi over 4. And then we have to go a little bit further to make one revolution. Well, after 7 comes 8. So 8 pi over 4 is what we have there. So notice that instead of doing counting of wedges again for 60 degrees or pi over 3, right? Why don't I just go over here to where it says pi over 3, the last 5 pi over 3. And that means if I need to keep going to make one revolution, I should have 6 pi's over 3. All right? And again, we could have proven it up here with the drawing. That was one wedge. Here's another wedge, 2. Here's another wedge, 3. 3 plus 3 is 6. Okay? So I wanted you guys to notice those numbers because these are all important. 12 pi over 6. Why did I do it that way? 12 pi over 6, 8 pi over 4, 6 pi over 3. Those are all one revolution in the unit circle. That's how many wedges or arcs that you need to count to do one revolution. So keep that in mind, because in our problem, we're looking for 13 pi over 6. Now, when you guys get negative angles, I want you to ignore for now. Okay? I want you to ignore for now. Now, we know that tangent is y over x. So we need to use both coordinates when we find it, okay? Both coordinates. So let's go find 13 pi over 6. So 13 pi over 6 is going to be where? Well, when you look at this, you're like, wait a minute, the highest they see so far is 11 pi over 6. And then I know if I go a little bit further, I have 12, but I don't have a 13. So that's why you need to keep counting. I need 13 pi over 6, but the most I have in one revolution is 12 pi over 6. So I went all around and I got to 12 pi over 6, but I need to go a little bit further. How much further? Well, if I'm at 12 and I need to go to 13, I need to go one more pi over 6. And so I would stop right here at pi over 6. Okay, that's where I would stop. So right now, I'm at this dot right here, this green dot at 13 pi over 6. All right, again, trying to give you a picture of what we did. We started here at 0. We rotated. We got to 12 pi over 6, and we keep going, and we stop here to make 13 pi over 6. Now, what did I need in this particular problem? I needed the y over the x, which is these two. So y is 1/2, the other one is square root of 3 over 2. So I'm going to come over here and say 1/2 over square root of 3 over 2. And now what I'm going to do is cancel out the 2's, all right, and reduce it now to 1 over square root of 3. I need to rationalize and multiply numerators, denominators, and then simplify. Oh my goodness, wait, I made a mistake. Hold on. Go back here. I completely forgot. Okay, you know how we were here at this green dot? I am so sorry. I hate that I messed up here. What you need to do is not forget your negative. The negative of over here. Remember this negative right here? The negative says when you get to the point of your angle, you need to jump over the x-axis. Completely forgot to say that. So I'm highlighting here, and that means jump over x-axis. So what you're going to do with me is go back to your unit circle and visualize this. I am so sorry. So here's your dot. I need you to jump over the x-axis, okay? So notice how you're just jumping straight over the x-axis, which is this one right here, okay? Don't forget this is your x-axis. And you are going to actually use this green dot. So I'm going to put an asterisk, okay? So our work is not going to change that much, so don't erase your work. This time, my x is square root of 3 over 2, and my y is negative 1/2. I am so sorry. So come back over here, and this is supposed to be negative. So this will be negative, negative, negative. So that's the only thing that's changing in this problem. I hate that I messed that up, but hopefully I didn't mess your understanding. So please don't do what I did. Treat this problem like a positive angle, but when you are done finding that angle, jump over the x-axis, okay? All right, let's try another one, and let's hope I don't mess this up. Let's not mess this one up, Christine. Okay, so cosecant of negative 5 pi over 6. So what does cosecant mean? All right, so cosecant means that we need to take the reciprocal of y. Oh, I never did any secant. I should have done one. Okay, so the reciprocal of y. So I need the y coordinate at this angle. Let's go to 5 pi over 6. So 5 pi over 6 is where? So 5 pi over 6 is right here. So all we had to do was rotate and we arrived to 5 pi over 6. We needed the y. So all I needed to do is take the reciprocal of the y. So 1 over 2 becomes 2 over 1, which is just a 2. And I am done. Simple as that. Okay. I think I have one more problem for you guys. There we go. So let's look at this one. Cosine of negative 17 pi over 3. So cosine requires us to find an x value, and that's it. Now, here's that infamous negative that I forgot last time. We're going to ignore for now, but remember to come back to it. So we need 17 pi over 3. So we come over here and we look for 17 pi over 3. Now the problem is, let's see, our last pi over 3 was 5 pi over 3, and we had to go a little bit further and we get to 6. I need 17 pi's over 3. So that's not enough, okay? 6 is not enough. So let's do this. If I started here and I rotated, that's a 6 pi over 3, right? And then if I rotate it again, 6, let me do another color. I'm at 6, and then I continue rotating in pink, and I get another 6. I'm at 12, but I'm still not at 17 pi over 3. So I'm going to rotate again, so at 12, and I need to keep going. Let's see what color. Let's do green. I'm at 12 pi over 3, and I keep rotating another 6. Well, 12 would make 18, and I don't need to go that far. Remember, I just needed to go to 17 pi over 3. So let's backtrack. The purple was the first 6. Remember, this is 5, so one rotation makes a 6. So I'm at 6, plus another 6 with the purple makes 12. How much further do I need to go? 12 plus what is 17? 12. For you visual learners, I'm already at 12. 12 pi over 3. Plus what will give me 17 pi over 3? Well, I need 5 more. 5 more. So where's 5 pi over 3? Well, 5 pi over 3 is right over here in the 4th quadrant. So I'm going to keep going. And it's not the best circle, and I stop right here. Here's my 5 pi over 3. Okay, so I was needing the x value. There's my x value. I think that's what I needed, right? Yes. I needed my x value at 17 pi over 3, and that's a 1/2. And I'm done. Okay. So just keep counting based on the fraction. Oh my gosh, I did it again, you guys. Holy cow, why do I keep doing that? Go back. You do not stop there. Okay. We got to 17 pi over 3. Oh my gosh, this is so aggravating. We got here. And then do not forget to jump over the x-axis. So I'm going to go over the x-axis right here. I can't believe I just did it again. Oh my gosh. Hopefully through my mistakes, you guys know not to do this, okay? So this is the one that I'm supposed to look at. So I am supposed to look at this x. It just so happens that it's also 1/2. So my answer still is 1/2, but my explanation and analysis, again, was flawed. So please don't forget to jump over the x-axis as I am completely showing you what not to do, okay? Hopefully that has helped, and thanks for watching.